In the Unit 1, Part 3 notes, we're going to start looking at function machines and function notation. So it says problem 1, a function works like a machine as shown in the diagram below. A function is given a name that can be a letter such as F or G. The notation right here represents the output when X is processed by the machine. This is called F of X. That's how you read it. When X is put into a machine, F of X, the value of a function for a specific X value comes out. In this notation, F of X replaces Y. So here's our machine. Think about a vending machine. You're putting in your input, which is your money. In this case, we're plugging in a 3. You're going to do your function, and out comes your output, which is going to be your number 8. So when we see F of X, don't let that confuse you. It's the same thing as saying like Y equals. It's just giving it a name. So numbers are put into the function machine. In this case, F of X equals X squared minus 1. The function squares it and then subtracts 1 to get the output, which is 8. The notation, F of 3 equals 8, shows that the function named F connects the input 3 with the output 8. So what we're going to do for problem A is we are going to use the same function machine, but now we're going to plug in the number 4 in for X. So you will see it says F of 4. Don't worry about that. That's just saying we're plugging 4 into the function. We're going to take 4 squared, or 4 times itself, minus 1. So we're doing this part here. So 4 times 4 is 16. 16 minus 1 gives us 15. So the way we write our answer is that F of 4 equals 15. So when we plug 4 into our function, we're going to get 15 as an answer. So we're going to do the same thing with negative 1. So we're going to take negative 1 squared minus 1. So negative 1 times itself is 1. 1 minus 1 is 0. So F of negative 1 equals 0. And then we're going to solve using the number 10. Still the same problem. So 10 squared minus 1. So that's going to be 100 minus 1, which is 99. So F of 10 equals 99. For problem C, it says if the output of the function is 24, what's the input? That is, if F of X equals 24, then what is X? So in this situation, we know the function, and we know that what's coming out is 24. We want to find out what are we plugging in. So we could guess and check a couple different ways. We could solve it algebraically by adding 1 to both sides. So X squared now equals 25. And then to undo squaring, we're going to square root. So X could equal 5. Now, it says, is there more than one possible input? There are. X could be 5 or X could be negative 5. Both of them, when plugged in, would give you 25 minus 1, which is 24. So the rest of the notes for this are going to be dealing with function notation examples. And this is kind of what you're going to be seeing when you go to do IXL Q7. You're going to be given a function. So for example, g of x is negative 3x plus 1. Or if we're given f of x, that's x squared plus 7. And we're going to be giving a number in a parentheses. So for example, for A, we're going to do g of 10. So that means we're going to take the g function, which is negative 3x plus 10, but instead of negative 3x, we're going to do negative 3 times 10 plus 1. We're going to calculate, so we get negative 30 plus 1, which will give us negative 29. So we are replacing the x with 10 for letter A. For letter B, we are taking our function f, so we're taking x squared plus 7, but instead of x squared, we're going to do 3 squared plus 7. So we'll get 9 plus 7, which will give us 16. So you are replacing the x with that number. We take a look at letter C. We're doing the same thing, but now we're plugging in -2. So we're going to take -2 squared plus 7. So that gives us 4 plus 7, which is 11. Okay. Now, the last two, we are going to find out what are we plugging in to get out 16 and to get out 23. So for letter D, we are using function G. So I'm taking -3x plus 1 equals 16. And I want to figure out, okay, what could I do? What could I multiply by -3 and then add 1 so I get an answer of 16? I'm not a very good mental math person, so I'm going to write down my problem and do it algebraically. So I end up with -3x equals 15, and if I divide both sides by -3, I get x equals -5. If I go back and plug it in, -5 times -3 is 15. 15 plus 1 is 16. So my missing input is -5. For the last problem, we're going to do the same thing, but now with function f. So we're taking x squared plus 7 and setting that equal to 23. So again, I'm not going to kind of guess and check. I'm going to solve algebraically. So I'm going to take 23 minus 7, and I'm going to get x squared now equals 16. And then to solve for x, I'm going to square root both sides. So we have 4, or we have -4, because both, when you plug them in, 4 squared is 16, and -4 times -4 is also 16. And then when we add 7, we will get 23. So this is a good example of what you're going to be doing in IXL Q7.